Alright guys, today I'm gonna show uh, how to open the previous runs, the topology extraction runs, and then analyze the waveform, measure the rise time, fall time, the topology parameters, how to change the um, data rate, the pattern, and to decide how to change the IBS model, what IBS model says roughly, and what else. Yeah, and to check the history of the runs. Let me quickly open the topology Sigrity workbench. So this is the topology workbench. I'm going to open the previous run. This was the run that I had. So this is my layout folder, um, and this was the file that was generated. So we want to check for top X files. So whenever you extract a topology from a layout, right here, when you start extraction, if everything is extracted successfully, the Sigrity Aurora will generate a folder in your working directory, um, and with a project name, and you can, if you open the folder, there will be topx. This is the main file that you want to open. Yeah, here it is, and rough quick background. We were trying to simulate this particular net here. Starting from the schematic, we did the simulation right here. I'm highlighting the signal test underscore sig, and this is the same net in the layout, and this is the net that we're going to simulate. It goes from layer bottom layer to top through via one, and goes down back to bottom. This is just for testing, and you can see the same right here. Bottom trace via to the top, top trace via to the bottom, and bottom trace. Yeah, all right. So this we have the same topology here from U56 or U59. It's the same thing. You have a trace via then top trace, top layer trace, and goes back down to via and bottom layer and the bottom trace, and then you have the device. So yeah, let me quickly run this before. Okay, so so whatever I ran earlier, the past runs, I can check them actually. These are the past runs. Explore. Yeah. Um, yeah, as you can see, all the test runs are there in the history. Uh, two. So yeah, you can see everything is here. This was one of the transient runs that we did earlier. Yeah, so you can recover all the past runs. So um, this is the TX signal and uh, RX signal, and this is the TX signal. And the IBS model that we use is this one. So it's a default IBS model from Cadence, 2.50 volt to 2.5 volt logic with 10 picofarad load. And roughly regarding the IBS model, this is what IO buffer specification. So every chips will have ESC protection, some load capacitance coming from the lead frame, lead package, or wire bond, inductance. All those things has to be incorporated to have an accurate simulation. Um, so if we quickly go here, this is what I saw. Where was that? Assign model. Let me click any one of them. Create model. Yeah, so resistance, inductance, capacitance. So yeah, coming back here, so we have the history, how to recover the history runs, and where is it located. You can easily see from here. So if you want to open the location, just right click and explore, and it will pop up. It will jump to the uh, directory where the run is located. And yeah, so for example, if I want to, um, if I see the eye diagram, this is how you can see. Um, and if I want to check the run 10 on top of, okay, let me click here. Yeah, so this is run 10. You can compare the two runs as well. Um, yeah, so one is at, I remember, if I remember correctly, this is at um, zero point 0.1 gigabits, and this is at 0.01 gigabits. Um, so let me go in here and let me disable the eye diagram. Let's measure the rise time of this plot right here. So in order to zoom in, you can click this bottom, this area select. If you want to fit the plot, this is how, this is the yeah, you can click here to fit. And let me enable the marker boot horizontal and vertical, and you can roughly measure from 10% to 90% rise time. Let me zoom in further from here to here. Okay, yeah, so roughly around, yeah, so yeah, 350. So I can do the same measurement by using this right here. So this is history to 11 and receiver is 56. 56 is the receiver, as you can see here. RX is here. We've made 59 as transmitter, and you can see the same here. 56 U56. Apply. Um, okay, it's saying 627, right? Mm, the correct one, history to, okay, 600, 627. So, oh, why is it from minus 2.5? Mm, okay, let me run. Let me start a new run. Um, because the rise time was not able to pick up properly, measure rise fall time. 10% should be like, if I remember correctly, it should be 0.0.1 to 2.16 roughly. Yeah. If I delete this, press is okay. 10 to 90, 0, 2.5. Is it the way it should be. No, I'm going to get the right stuff. Okay, anyway, so this is somewhere here. Yeah, so around 400 is the rise time. So we can roughly measure it. So let me rerun again. Um, check connectivity. This is fine. Alright, check analysis option 0.11010 pattern, which is cool. And we are looking at run number. Let's run again. Yeah, result 3. Cool. Measure rest and full time. Okay. Let me enable TX signal as well. Observe rest and full time. Okay, it's picking up the spike. 0 to 2.5. Okay. I see 437. Both the rise time and fall time. Let's check. 437, right? Is in here and further here. Measure difference. Let me enable only. Yeah, let's enable both. We're looking at the receiver signals. Space through this. Yeah, how much it was? 437. Yeah, I think that's what we are getting right now. So 10%. Oh, I don't have mouse. This is painful. Yeah. Anyway, so for 450. Yeah, I'm not able to place the cursor accurately. Um, all right. And what else do we need to discuss? With time series analysis. Yeah, I think that's all. Okay, let me so a quick run other parameters as well, like 0.1. This is what we are getting, and at um, 0.01, this is what we have, and 0.1, this is what we have. Yes, simulating. So the overshoot is most probably because we don't have an accurate IBIS model. Um, yeah, so that can be fixed later, but at least we know how to run the simulation. What I really want to check is the stimulus, if I can have a CSV file where I can model the waveform that I want, and I give that as an input to the transmitter side and check the signals at the receiver side. That's what I wanted to do, but it seems like there's no such features on the analysis option. Um, yeah, define pattern preview. Oh, I see a data file. Oh, cool. Yeah, this is nice. This is what I want. Okay. What I'm gonna do is I'm gonna make another video with this data patterns. Um, yeah. For now, I have not explored yet, so I'm gonna make another video for this. Cool. All right. For now, I'm gonna end this video right here. Uh, I thought of making a short video, but it ended up being long, I guess. Ciao, guys.